All right, welcome back to KM6LYW Radio. This is a show about amateur radio with an emphasis on data modes, trying to reimagine them kind of in the information age. No data mode radio combo would be complete without a Raspberry Pi. We're going to talk about that a lot here. In fact, we've got the DigiPi project here, which is kind of a culmination of all of the technologies we talk about on this program. So that's an SD card image you can get there at krieger.org/digipi. We're going to talk a little bit more about the DigiPi. In fact, you might notice that this DigiPi here has no wires. That's what's new about this one. Let's talk about that this time on KM6LYW Radio. All right. That's the bumper music, and welcome back. YouTube suggests that you guys like classic rock, so we're going to take it down a notch there. Do a little Eric Clapton for you guys. All right, so we said the DigiPi has no wires here. I mean, technically it's not talking to the radio, but we could figure that out if we use the Wi-Fi capabilities of this. But right now, you'll notice that this DigiPi has a new item on it here, and that's underneath here. We've got an actual battery. This is a Waveshare uninterruptible power supply, UPS battery. So I don't know, how do you guys power your Raspberry Pis? Initially, I was thinking, well, this looks kind of steampunky. It's not as elegant as I'd like. I mean, ultimately, my goal for the DigiPi project is to come up with something as elegant as, the Mobile Link D TNC. And this is pretty cool for an FSK modem. Of course, it doesn't have a screen or anything. So this has an internal battery. So I was trying to figure out how we're going to power the DigiPi project. I mean, normally, this isn't exactly elegant either, trying to use a cell phone backup battery with your DigiPi. I mean, it works, and that's what I've typically done. But Mahai, I think I got your name right there. You suggested the Waveshare battery backup, and that's what I installed on the bottom of this DigiPi here. So it's it's probably better show it on the web, but it's a lithium-ion battery that kind of straps to the undercarriage of your Raspberry Pi Zero, and of course they make other ones for the different types of Pis. There's no soldering involved. What's kind of the genius about this thing is the fact that there's these little what we call pogo plugs. I think that's what they're called. These brass things right here. They're squishy. They're spring loaded, and they actually touch the back of the Raspberry Pi in just the right place, so it can provide power. And it also is on the I2C bus, so we can manage the power, see the current, see the voltage. Maybe you want to shut the Pi down, or maybe just do something if the battery's going to wear out. In fact, what I might do is put a status screen on the DigiPi saying maybe, hey, this is your battery voltage. So if you want to add a battery to your DigiPi, you can certainly do that. There's a couple of different options. I think I've got them here. This is the Waveshare one that I like. It's 1,000 milliamps, so that's 1 amp hour. If this Raspberry Pi burns 200 milliamps, it will run for 5 hours on this battery. And for me, that's enough. And it charges quickly as well when you just plug the USB into the side of this thing, and it just starts charging the battery. And then the one thing I wasn't sure about that I think I like the most is this actually comes with a power switch. So in the first time in history of the Raspberry Pi, you get a power switch on your Pi. You don't need to plug it in or wrestle with wires. You just want to turn it on and off. You just do that right here. And of course, with the DigiPi, with a read-only file system, you can just turn it off whenever you want. So just turn it off and on, just like anything else, just like the Mobile Link D, right? That's these guys have just done a fantastic job with the Mobile Link D. So that's kind of what I've patterned this after. So again, you can just turn this off and on. You don't need power wires anymore. You don't need this disaster if you can get a backup battery. Now, for connecting to the ICOM, for audio, you still do need like the the traditional audio cable that's plugged into the side of the ICOM 705 to do that. And then, of course, if you don't have a USB capable radio, you can get the little audio hat and and do it that way. But again, everything can run off of this battery. There's just one less thing you need to bring to your Summit on the air operation. You don't want to have to worry about bringing this backup battery to power your Raspberry Pi if you're doing data modes. Again, this is just for maximum portability. So the Waveshare is one of these. I don't know if they describe exactly how it works here. At one point, I think they show the pogo plugs. I don't know, this is probably as good as it's going to get. You see the pogo plugs here. These touch the bottom of the Raspberry Pi. It's just totally ingenious design. Pretty cool. And I don't know if they got another relevant picture here. Ultimately, it straps that battery under the undercarriage of your Raspberry Pi Zero. That's what the bottom of it basically looks like. Guys, we desperately need a case for this. You know, you guys are saying how awesome your 3D printers are. Could you guys possibly come up with a case for this guy? You know, that maybe is flexible. Maybe it's I don't know if it's a clamshell or something, but you know, we can get a case on this thing. And, you know, the Mobile Link D is really what I'm patterning a lot of this after. So we can get a case that kind of looks like this. Of course, you know, we have a screen and everything. This kind of flexible as to how many cards you might have on your DigiPi. That would be cool. All right, so this is the Waveshare. These are the Pogo. Actually, I can zoom in here kind of. These are the Pogo plugs here. I don't remember what the actual wattage is on this or what the total current drain is. I don't think there's any limitation that the Raspberry Pi Zero is going to exceed here. So this is the Waveshare. And it's cheap too, $24. So another one, and this is another alternative option for battery power, is going to be the Pi Sugar. And this has been around a little while longer. It's a very similar in concept. The one difference is that for the Waveshare, the battery is on top of the board and then smashed under the Pi. And for this, it's just kind of the opposite. The battery is on the very bottom, and then there's the Pi Sugar board, and then that's almost laminated, within 1 millimeter of the bottom of the Pi. So this actually buys you a little more power. You get 1,200 milliamp hours. With the Pi Sugar. There's also a magnet that kind of holds this together, and then they actually say an iron plate at some point. I don't know what the weight was in this guy, so I'm counting grams, right? For backpacking, we're doing summits on the air. I'm sure this is a totally capable battery UPS system. The implementation is slightly different. They actually have, instead of pogo plugs, they use these little kind of spring-loaded surface mount I don't know, springs, I guess is for lack of another word. And it fits perfectly on the bottom of the Pi, and you can just laminate these two things almost, just really close together, and then the battery rides under that. I think both of these, they have different Pis, because they've done a couple of different revisions of the Pi Zero, so you need to make sure you're using the right Pi. And that's how it laminates together. Hopefully you can stack additional cards on top of this. Once you laminate these two together, the Pi Sugar with the Pi Zero, can you still add additional cards and have them mounted with the mounting hardware? This is Pi mounting hardware. Let me know if you get the Pi Sugar. I'd kind of like to know that. I should just get them both. They're roughly the same price. So this is $38 on Amazon. I'm sure you can get it cheaper if they have a website. Whereas the UPS hat from Waveshare, $24 on their website. You get a little more battery on the Pi Sugar. But again, if we're running at 200 milliamps, which we typically are on a Pi Zero, maybe 350, I've seen it up to 600 or so if it's really running flat out. You're getting 4 or 5 hours out of a 1,000 milliamp hour battery. So managing this, there is a device on the I2C bus that this provides. In fact, if you go to waveshare.com/wiki/UPS_hat, they actually give you the commands here to run this, to manage your Pi. Let me go over to this DigiPi that we've got over here. It's actually running on the battery. So this is the command interface for the DigiPi. It's just a web front. Of course, you can do this on your computer. You can do this on your tablet. It's a web front. You can run all amateur radio apps in all modes from here, all using your Wi-Fi device or phone or tablet or computer. And you'll notice there's no keyboard or screen here. It's a Wi-Fi data hotspot, right? It should be accessible. That's what we're doing on this channel, is making amateur radio data modes accessible. So if it doesn't run on your phone, man, it doesn't run at all, especially if you're a teenager, right? All right, so I'm going to open the shell on the DigiPi here. If you've never used a Raspberry Pi before, actually I just typed it wrong. The username is always Pi, and the password is always Raspberry. The DigiPi is no exception by default. You should obviously change it once you get yours. So here we go. I got a command prompt in the DigiPi. Now let's take a look at the battery. So the commands to I'm going to become root. There we are. I think a CD. Can you guys see this? I can zoom in a little more. So at their, actually have commands here where you do a sudo apt-get install p7-zip. I don't know why this is so small. Can I go bigger? I'm trying. That text just doesn't get a lot bigger. Of course, it's lagging. All right, so you want to install p7-zip. For some reason, they use p7-zip. Don't use p7-zip. Use gzip, okay, guys? So you can wget this file. Actually, I'm just going to cut and paste this. Yeah, it's not cut and pasting. You know what? I already did this. Anyway, the commands are here. I've already got this copy of this Python script. So the Python script is called ina219.py. I don't know why this browser is freaking out. You know what? It's these pop-ups. If you make a website, don't do pop-ups, please. I'm begging you. Anyways, get an ina219 script, okay? And then we go back to our shell. And I've actually got one here. When you unpack it, it's in a directory called USB UPS hat. All right, and then there's an ina219 script. Just to be sure you've got it there, you can do an I2C detect. You don't have to do this. -Y1, and you'll actually see the I2C bus. Now you can have multiple interfaces on here. In fact, if you have a DigiPi that has the audio hat on it, the FE-Pi or the audio injector 0, you'll see two devices here. So here we see device 43. And then, if we had, I think it was something like 33, you'd see another device here for your sound card. So we'd see device 43. We have something on the I2C bus. We don't know exactly what it is. But this script here, this ina219 script, will look for that device and actually pull the voltage, the current, percent of battery. I had to hack the script up a little bit. All of the currents are off by a factor of 10. I think the reference resistor that they use in this device is 0.1 ohms versus 1 ohm. But anyways, that was easy to fix. And also it chose the wrong I2C device. It chose device 44, and we can obviously see it's on the I2C bus as device 43. I mean, you can hack on this if you want to. But you can define, I had to go in here and tear this apart, so you can actually define the device address right here at the bottom of the script. The address is 0x43. This threw me for a loop for a while, so I was like, well, let's look at the bus. Where's the device? Okay, so I'm 43. I think it's because I have this configured to have other I2C devices, multiple I2C devices, including those audio cards, and that's why it was weird. And of course, I modified it just a little bit, this whole factors of 100 versus 1000 when we're printing stuff out. So let's run this script. ina219, and here we are running it, and it just repeatedly, I'm going to zoom this in, over and over tells you what the voltage is, the current in amps, the power, which is volts times amps. I mean, you could do that in your head, I guess. And then the battery percentage available. And I just kind of modified that as well. So you're going to get a modified version of this on the DigiPi. In fact, it's called power.py. And it'll give you more accurate display here. So, they had the battery being dead at 2.4 volts. You shouldn't draw lithium cells down that far. In fact, I would hope it cuts off power at that point, the battery management system. So I set it down to about 2.7 volts as being dead. It's at 57.9 right now, but what I want to draw your attention to, if I can zoom this in anymore, I don't know if it's going to let me. It's scrolling is what it's doing. Let's see if I can zoom this. I don't know if we go up here. Anyways, I'm going to move this up a bit. And so we're burning 265 milliamps, 263. That's not a lot. It's not exactly a little. What can we do to actually save power or kind of exercise this? How can we benefit from knowing this? Well, there's certain things we can do on the DigiPi. Like right now, the Direwolf is running. You can see it's been loading call signs. Actually, it's not hooked up to the audio, so it's not doing that imminently. But the decoders are running. So I'm going to take the DigiPi. I'm just going to put it into standby mode. Actually, this is a feature of the unreleased DigiPi. So don't try this on yours. Now it's in standby mode. And we went from, I'm scrolling up, 265, 270, and now we are down at, well, 260. I guess Direwolf wasn't really killing it. Or it might, I bet you it stopped because it was, because the audio device wasn't connected. So 265, I guess, is what this really is idle. That's good to know. There's other things we can do. I've optimized the power on this device to best of my ability, but there's one other thing we can do here, and that is turn the HDMI adapter off. So again, let's watch the milliamps. We're at 260, 270. If we type TV service -O, this is going to kill the HDMI subsystem and save all that power. So I'm going to turn the TV off. Now this means you won't plug it into a television or your monitor and hack on it. Now DigiPi wasn't meant to do that, but I know the first thing you guys always do is plug the keyboard and monitor into this Raspberry Pi for DigiPi. Just like any other Raspberry Pi project, you don't have to do that. It pops up as a hotspot or joins your Wi-Fi network. You don't plug a TV or monitor. So knowing that, you guys can actually run TV service -O, and it says powering off HDMI. Now watch the power go from 268. Oh, I already powered it off too. Anyways, this might be as low as it goes. So it's in standby. The TV is off. I didn't set this up very well. But maybe there's other things you can do to help save power, because power is going to buy you time. So 269, you can run top on a Raspberry Pi and see what processes are burning. So right now I have got 99.8% idle. I've got all of the subsystems disabled that I can find. That TV service I think was about 30 milliamps. So that would save you about 30, even though this wasn't a good demonstration. So in top, I'm seeing it's 99% idle. So I think this DigiPi is saving as much power as it possibly can. PSA, look for Direwolf. I don't think it's running. I think it quit because I yanked the sound card. Yeah, it's not running. I can fire it up here. Let me, actually on DigiPi it's called power.py. Let me fire up. I'm going to plug in the audio this time so Direwolf doesn't lose its mind. Plug that dude right in there. And now it's got audio, and now we're at 270, 272. I'm going to start Direwolf, which is the TNC, the AX.25 TNC or iGate. And we're at 284, 301. It's kind of a negative test. 285. 299. So what did we come up, 20, 30 milliamps just running the TNC here. Of course, I don't know if we're plugged into, I think we're plugged into the HF antenna. I don't know if we're going to get many packets here. But anyways, the software decoder is running, and obviously we saw the power go up. So let's keep an eye on that battery percentage. We're seeing that dip down. I use this in the backyard for maybe, I don't know, 4 or 5 hours. I was actually charging it while I was using it using nothing more than this guy. They make a double version of this too. And it was running just fine. And this will do like about 700 milliamps. So this by itself will run the Raspberry Pi. So you can just plug this into the side of the UPS adapter. If a bird flies in front of this, the UPS, the battery will keep the Pi running. And this you can run indefinitely on one of these cheap little USB-based solar panels. And that's what I was doing yesterday. So it runs forever. In fact, I was using a similar version to actually power the ICOM 705 here. And I could kind of keep its battery charged up over USB as well. All right, so let me know what you guys do for Raspberry Pi power. These are just a couple of choices. It's not absolutely necessary, but it sure is better than trying to use a backup battery and less cables, less complexity, the better, and the price is right. All right, so that is power. So I can't thank you guys enough for being patrons. If you like the channel, I really ask that you like and subscribe. That does help me a lot. Now we're well over 1,000 subscribers now on YouTube. This has completely exceeded my expectations, and this is because of you guys. I'm sure I would not be doing this if it wasn't for your support. So if you can help me out here for patreon.com/KM6LYW. I will buy all of this kind of silly junk and test this out so you don't have to. That's where all of these little devices come from. I really appreciate it. So at the top of the list, I think you guys have been supporting me the longest. BS, that's actually Brian Schultz. It comes through as your initials. That's Brian Schultz, Jake, Dan, Christopher. I'm skipping through these. Kevin, you're still on there twice, man. You want me to remove you? I don't know. All right, Aaron, Scott, Joshua. It's just too many now. Ronald, John, unbelievable. PD1, PME. Hey, I did print out your base for the 705. I think I mentioned that in my last video. Walt, if you're watching, I know you got it. Maybe we can drop that in the mail. Jeremy, Scott, John, James, A Kiddo, all the way down to Charles B. Jesse. Hey, we are hanging out on Discord. If you guys do Discord, I don't know, where is that? This is where we talk about DigiPi stuff. Steve actually built a cable using the CM108 audio dongle. It actually has a secret push-to-talk pin on it, so Steve's been messing with that. Actually got hamlib compiled. So anyways, these are the patrons. This is us hanging out. We've got a mailing list. If you're interested in the DigiPi, go to Krager.org/DigiPi. Krager.org/DigiPi, and if you chip in something to the Patreon thing, you get the SD card image that includes all of the technologies that we talk about here. It gets you into JS8 call, FT8, FL Digi, which is dozens of modes, including CW, slow scan television, all of the AX.25 networking, APRS, packet stuff, all of that's included here, and you just plug it into any radio and access it exclusively using a tablet or cell phone. That's the DigiPi project. And this supports the channel immensely. Putting this together, this has just been a lot of fun, and you guys are really helping me develop this. I've got release candidates now for 1.6 Mark II, so that's coming out imminently. I don't know, days. I dare I say weeks. Okay. Thank you so much, patrons. I will see you next time on KM6 LYW Radio.